Scientists find ways to make Mars surface fit for agriculture. July 17, 2019. The Ergo board mimics Earth's greenhouse effect and can help create fertile oases on Mars. Scientists find ways to make Mars surface fit for agriculture. Mars is frigid, dry and bombarded by radiation, and its soil contains potentially toxic chemicals. Photo, NASA JPL. For future astronauts bound for Mars, it will certainly be a plus. When they sit down to dine on the barren red planet, they must at least have plenty of greenery. The hostile environment on Mars has always made food cultivation a frightening prospect, but scientists believe it has broken the problem with sheets of material that can turn the arid and cold surface into soil suitable for agriculture. The Ergo plates work by mimicking the Earth's greenhouse effect, where the sun's energy is trapped in the planet by carbon dioxide and other gases. Scattered in the right places on Mars, the sheets would warm the soil and melt ice enough to keep the plants alive. Robin Wordsworth of Harvard University, who worked with these boards, said, "If we want to create sustainable habitats on another planet using current technology, this approach can be very useful. It is completely scalable, so the covered area can be anywhere, from a few square meters to large regions of the planet. If humans decide to spread beyond Earth, as the late Stephen Hawking declared we should, then growing food on alien worlds should be a skill that has to be mastered. But on Mars the conditions are hardly propitious. The planet is cold and dry and bombarded by radiation. The soil contains potentially toxic chemicals and the rarefied atmosphere is low in nitrogen. In the past, science fiction scientists and writers have proposed sterile terraformed worlds, an approach that requires the entire atmosphere to be rebuilt. In 1971, American astronomer Carl Sagan suggested that the vaporization of the North Polar Cap on Mars could release enough water into the atmosphere to do the trick. More modest ideas involve building greenhouses. Ergo sheets do not solve all the problems, but they can help future planters create fertile oases on desolate planets where plants and other photosynthetic organisms can take root. Because life would only grow under the sheets, the risk of contaminating the rest of Mars with foreign life forms would be minimal, Mr. Wordsworth said. The Ergo used to make the plates is composed of 97% air, with the remainder composed of a light silica network. Researchers, including scientists at NASA and the University of Edinburgh, showed that 2 cm to 3 cm thick silica gel plates blocked harmful UV rays, allowed visible light to enter into photosynthesis, and trapped enough heat to melt frozen water locked on Martian soil. The researchers wrote in Nature Astronomy, placing silica Ergo shields over sufficiently ice-rich regions of the Martian surface could therefore allow the photosynthetic life to survive there with a minimum of subsequent intervention. Plates could be placed directly on the ground to grow algae and aquatic plants, or suspended to give rise to terrestrial plants that grew below them. Wordsworth said, "The best place to try this is similar to where you want to land humans, in mid-latitudes where the levels of sunlight are still relatively high, but close enough to the polar ice caps that the ice deposits near the surface are still scattered around." You can imagine this being used in many ways. The most viable in the short term would be a small-scale test with a robotic probe. In the long run, this could be used in support of human exploration missions and ultimately to produce long-lived habitats that you intend to make as self-sustaining as possible.